Alright, so this is the in-class activity that we did during week 1. And so number 1, you want to solve this following equation. And this is a linear equation. So if you notice that there are no variables in the denominator, the variables are located in the numerator, and all of the variables, in this case x, are being raised to the first power. So x to the first, x to the first, x to the first. And so notice also that this linear equation has fractions, and so what we want to do is we want to clear those fractions. And so we're going to clear the fractions by finding the least common denominator. And so we want to find the smallest number that 4, 3, and 2 will go into, so that way if I multiply this fraction by the least common denominator, 4 will divide into it. So that least common denominator will be divisible by 4. Same thing here. So whatever I multiply this fraction by, I want to make sure that that number right here, that least common denominator, is divisible by 3, and this will be divisible by 2. So the whole idea when clearing the fractions is to get these denominators to be factors of 1 instead of 4, 3, and 2. And so notice that the smallest number, and always use the smallest, you can use a common denominator, but it's always easiest to use the least, the smallest. So the smallest number that 4, 3, and 2 will go into evenly is 12. So 12 is going to be my least common denominator. Now what we're going to do next is we're going to multiply both sides by that least common denominator. So that's our next step. So we're going to clear the fractions. So once you find the least common denominator, we're going to multiply both sides by that least common denominator. What I do to one side, you have to do to the other. Notice though that this left-hand side has two fractions, this fraction and this fraction. And so I'm going to put that in parentheses. I'm going to close that in parentheses. So I'm going to get 3x minus 1 divided by 4 minus, and then x plus 2 divided by 3. Okay, I put that in parentheses, equals, and then I'm just going to leave some space here, and then x plus 1 divided by 2. And at that point, I'm now going to multiply both sides by that least common denominator. So I'm going to multiply the left-hand side by 12, and I'm going to multiply the right-hand side by 12. Notice, though, that I did include parentheses. So I did, at some point, place some parentheses here. So now I've got to get rid of those parentheses. And so one way to get rid of those parentheses is to use the distributive property. So I'm going to multiply both of these fractions in here by 12. So I get 12 times 3x minus 1 divided by 4 minus 12 times x plus 2 divided by 3. And I'm going to go ahead and leave this alone for right now. 12 times x plus 1 divided by 2. And now we're at the point where we can reduce these fractions. Remember what we said. We wanted this least common denominator to be divisible by 4. We wanted this to be divisible by 3, and we wanted this to be divisible by 2, and they are. So 4 into 4 is 1 time. 4 goes into 12 3 times. 3 goes into 3 1 time. 3 goes into 12 4 times. 2 goes into 2 1 time. 2 goes into 12 6 times. And notice what we said, we wanted 1s as factors in those denominators. Now be careful. So what you may want to do now is notice that this numerator right here is being multiplied by 3. So if you're not careful, you're going to say this is 3 times 3x is 9x and then minus 1, and that's not correct. So what you should do is this. So everything in that numerator is being multiplied by 3. So put parentheses again. 3x minus 1 times 3, same thing here, minus 4 times x plus 2, equal, and then 6 times x plus 1. So that will help to make sure that you don't make the mistake and forget to multiply negative 1 by 3, positive 2, and let's go ahead and use the negative 4 here, and then a positive 1 times 6. Okay? So now we're going to use the distributive property again, right here, on both sides. So I get 3 times 3x is 9x, 3 times the negative 1 is a negative 3. Now distribute the negative 4 here, even though it says subtract 4. Remember, subtraction is the same as adding the opposite. So I'm adding a negative 4, so we can distribute a negative 4. So negative 4 times x is a negative 4x, and then negative 4 times 2 is a negative 8, equal 6 times x is 6x, and then 6 times 1 is 6. All right, now at that point, I'm going, and also notice at this point right here, I no longer have fractions. So we see we have this nice linear equation. So at this point, I'm going to combine like terms. So 9x minus 4x is 5x. A negative 3 and a negative 8 is a negative 11, equal 6x plus 6. All right, now at this point, notice you have variables on both sides and constants on both sides. So if you want to, you can bring the variables to the left-hand side. You can bring the variables to the right-hand side. It does not matter. Just be careful when you. There's one way that confuses people. So we're gonna do it both ways, just to show you that it really doesn't matter which side you bring the variables on. You just have to be careful. So if you bring the variables to the right-hand side, which is what some students would probably like to do, because the coefficient of x here is a positive 6, the coefficient of x here is a positive 5, and a positive 6 is greater than a positive 5. So they'll probably want to bring the 5x to the other side. Now remember, what you do to one side, you do to the other, and be careful, because I've seen this. I've seen students say, I'm going to subtract 5x like this, and then that's not true. You aren't subtracting 5x, you're subtracting 5, and those are not like terms. So be careful. You want to make sure that you're subtracting that term, not the coefficient of that term, but that term. So I should see this in order to get full points. Okay? Then combining like terms, 5x minus 5x is 0, so that's 0 here. And then we have a negative 11 equal 6x minus 5x is x, and then plus 6. And then I'm going to bring the constants to the other side. So right now I'm adding 6, so the opposite is to subtract 6. And the negative 11 and a negative 6 is a negative 17, and that's going to equal x. And then remember, this is 0. So positive 6 and a negative 6 are opposites, and so when you add opposites, you get 0. And you solve for x. So that should be your solution. Now, just to remind you, so remember right here where we had 5x minus 11 equals 6x plus 6? I'm going to go ahead and write this over. Oops, 5x minus 11 equals 6x plus 6. And then instead of bringing the 5x to the right-hand side, let's bring the 6x over, just so you'll see what you would need to do. So I'm going to subtract 6x from both sides. Now be careful, 5x minus 6x is not x. It's a negative x or negative 1x. Most students will say negative x, and that's fine. Minus 11 equal 6x minus 6x is 0. Those are opposites. And when you add two opposites together, you get 0. And then 0 plus 6 is 6. Then adding 11 to both sides, because right now you're subtracting 11. The opposite of subtracting 11 is to add 11. And I get negative x is equal to 17. All right, now remember, you're trying to solve for x. So at this point, you can think of this in two different ways. You can say the opposite of x is 17. So the opposite of what number is 17? Well, the opposite of a negative 17 is 17. Most students, though, what they'll do is they'll put a coefficient here of negative 1. So let's say negative 1x equals 17. And then to get x by itself, you can divide both sides by negative 1, just like this. And negative 1 divided by negative 1 is 1. That's what you wanted there. 1 times x is x. And you get x to be negative 17. All right? So just be careful which approach you take on that one. So that's the one that causes a little bit of anguish for some students. Okay, number 2. So we talked about complex numbers. And so notice that when you simplify a complex number or a fraction in which the denominator contains an I and it's a binomial, you want to get rid of that I. You want to get rid of that imaginary number. And since this is a binomial, one way, or the way to get rid of that imaginary number there, since this is a binomial, is to use the conjugate. All right, so we talked about the conjugate. So the conjugate of 3 plus 2i is 3 minus 2i. And it turns out that if you multiply now, let me go ahead and write this right here. So 3i divided by 3 plus 2i. So if we multiply now the numerator and the denominator by that conjugate, just like this. Now remember, it's just kind of like what we had before. Let me just remind you real quick. So it's just kind of like if you had, let's say, 2/3, right? And so we want to keep this fraction equivalent. 2/3 is the same thing as saying, I'm going to write 2/3, is the same thing as saying 2/3, so it'll be 2 times 5, let's say, 3 times 5. And it is because this is 2 times 5 is 10, 3 times 5 is 15, and when you reduce, you get 2/3. It does not matter what you multiply this by. As long as the numerator and the denominator are the same, this is always going to be 1, and 1 times 2/3 is still 2/3. And that's what I'm using here. So I want to simplify this complex or this complex number here, right? And so to simplify this complex number, I got to make sure that whatever I multiply it by, it's still equivalent to this. So whatever I multiply 2/3 by is still equivalent to 2/3. So in other words, I could have said 2/3 times 7 divided by 7, like that. 2 times 7 is 14. 3 times 7 is 21. When I reduce, I get 2/3 because they're both divisible by 7. 7 divided by 7 is 1. 1 times 2/3 is 2/3. Right? So that's what you're doing here. But the idea, though, is to get rid of this imaginary number. And since this is a binomial, to do that, you're going to multiply by the conjugate of that denominator. And the conjugate of the denominator is 3 minus 2i. So you multiply numerator and denominator by 2 minus 3i. All right, so now here's the work. So notice you have this monomial right here times this binomial. And so I'm going to write it like this, 3i, because remember this is multiplication, right? So 3i times 3 minus 2i, just like this. And the same thing here, you multiply the denominators together, but since each of those has two terms, let's put those in parentheses. 3 plus 2i times 3 minus 2i. And now I'm going to have 3i times 3, so I'm going to use the distributive property. 3i times 3 is 9i. 3i times a negative 2. Now be careful, I'm going to go ahead and do that here. 3i times a negative 2i. 3 times a negative 2 is a negative 6. I times I is I squared. So this becomes 9i minus 6i squared. Divided by, okay, now over here I have 3 plus 2i times 3 minus 2i. And so just like if you had 3x minus 1 times 2x plus 2, just like that, you're multiplying two binomials and you use the FOIL method. Same thing here. First, outer, inner, last. So you can do the same thing with this. So the idea still applies. So 3 times 3 is 9. The outer, 3 times a negative 2i is a negative 6i. The inner, a positive 2i times 3 is a positive 6i. Now I want to mention this. So since these right here are conjugates of each other, they're conjugates. The only thing that differs is that middle sign here. The outer and the inner will always be opposites. So when you add them up, you'll get 0. And then the only thing you have left is the last. Now be careful, right? I would write it out just like I did with this one right here. So you get 2i times a negative 2i. 2 times a negative 2 is a negative 4. I times I is I squared. That becomes negative 4i squared. So minus 4i squared. So this becomes 9 minus 4i squared. Okay? So then I get, down here, I get 9 minus 4i squared. Okay, so just remember, I guess I should have put this right here. I guess I can come right here and do it. So we had 3 plus 2i times 3 minus 2i, right? And so foiling, we get 3 times 3 is 9. The outer is negative 6i. The inner is positive 6i. And the last is minus 4i squared. The outer and the inner will always add to be 0 because those are conjugates. And when you multiply conjugates, the outer and the inner are opposites. And so you get 9 minus 4i squared. Okay? All right, now at this point, remember, this is where you want to remember that I squared is equal to a negative 1. So in place of I squared, you're going to substitute negative 1. So this becomes 9i minus 6 times negative 1 divided by 9 minus 4 times negative 1. So I squared, substitute negative 1, I squared, substitute negative 1. And so I get 9i. A negative 6 times a negative 1 is a positive 6. And then 9. A negative 4 times a negative 1 is a positive 4. And so I get, and I'm going to write this in the form a plus bi. So I get 6 plus 9i divided by, and the 9 plus 4 is 13. And again, writing the form a plus bi, so I'm going to write this as two fractions. I'm going to write the answer here now. I get 6 thirteenths plus 9 thirteenths I. All right? So that was number 2. And then finally number 3. So now in number 3, you have, you want to solve this following quadratic equation by using the square root property. Now many students, when they see this 3 out in front here, and when they do that, they want to think of this. So they see something that looks like this, and then they use a distributive property. Now using a distributive property here is correct. You can use a distributive property here. But here you cannot, because you cannot say 3 times 2x is 6x and then 3 times 3 is a negative 9. The only time you can use a distributive property like we do here is if that exponent right here is 1. Okay? 1. And notice this is 1 also. Here, my exponent is not 1, but it's 2. And so basically why that's the case is because of the order of operations. So remember, you have to do exponents first before you do multiplication. So remember, the distributive property involves multiplication. So if I really wanted to use distributive property, distribute that 3, I need to multiply this out first. I need to say 2x minus 3 times 2x minus 3, whatever that is, then multiply by 3. All right? So just to emphasize, you cannot use a distributive property here because this exponent is not a 1, it's a 2. But the idea, though, is that you want to use a square root property. So what you want to do now, what you want to do first, is you want to get rid of this coefficient of 3 here. Remember, that's multiplication. The opposite of multiplication is division. So I'm going to go ahead and rewrite this over. 3 times 2x minus 3 squared equals a negative 15. So I'm going to divide both sides by 3, just like this. And then 3 divided by 3 is 1. And so I have 1 times 2x minus 3 squared, I'm going to leave it as 2x minus 3 squared, equal, and the negative 15 divided by 3 is a negative 5. Now remember, always follow the direction. Direction says use the square root property. Some students will forget about that, and they'll FOIL this out. They'll multiply 2x minus 3 by itself, FOIL it out, and then use the quadratic formula. You got to be careful, follow the directions. Directions said not to use a quadratic formula, but to use a square root property. All right, so the square root property at this point, remember, is where, I'm going to write this over. All right, I left some space here. So square root property is where you're going to get rid of that exponent of 2. The opposite of squaring is to take the square root of both sides. But remember, when you take the square root of both sides, you end up getting a plus or minus. Okay? Which kind of makes sense, right? If you think about a very simple example such as x squared equal 9. So if x squared equals 9, what number times itself is 9? Well, when x is 3, because 3 times 3 is 9, and also when x is negative 3, because the negative 3 times the negative 3 is also 9. So if I'm going to solve this by using a square root property, then I've got to remember that I'm going to get a positive and a negative. So I take the square root, and I get plus or minus here, and the square and the square root undo each other, so you get x equal plus or minus, and the square root of 9 is 3, which is what you had here. So that's the idea that's involved here. Don't forget that plus or minus. You have to show that plus or minus at this point. You cannot just leave it out here and all of a sudden put in the answer. It doesn't work that way. All right? Okay, now the other thing you got to remember is this. I'm taking the square root of a negative number. Some students, when they're not very careful, they'll say that there's no solution. There is a solution. You've learned about imaginary numbers. We just talked about this in the previous example, the idea of imaginary numbers, right? So you can simplify this. Now remember how we did this. I'm going to go ahead and put that here. The square root of a negative 15, what we did in class was we said that this is the same thing as saying the square root of a negative 1 times the square root of 15. And we learned that the square root of a negative 1 is defined to be I. So I is that the square root of a negative 1 is an imaginary unit. So that's at I. And so this becomes I, and I cannot simplify the square root of 15. The only perfect square that goes into 15 is 1. So this stays the square root of 15. All right, now I tend to put when you have an irrational number like this, a square root of 15, I tend to put the imaginary unit on the outside. But if you want to, you can rewrite it like this, square root of 15, I, like that. Just make sure that that I doesn't look like it's on the square root, because it's not supposed to be. If you extend this like this, and that I, and it looks like this, that's not true. That's incorrect. It's not the square root of 15 times I. It is the square root of 15I, like that. All right, so be careful. All right, so now I'm going to replace this as, now remember, the square and the square root into each other. So you get 2x minus 3 equals plus or minus I square root of 15. So notice, plus or minus, you have to show that all the way down. And so now, since I have this imaginary number here, all I need to do is add 3 to both sides, just like this. What I do to one side, I do to the other, because remember, you're trying to get x by itself. 3 and negative 3 are opposites. Now be careful, those are not like terms. This, for one thing, has an I in it, this does not. Another thing is that this part right here, the square root of 15, is irrational, and 3 here is rational. All right, so those are not like terms. So what you want to do at this point is say 2x equals 3 plus or minus 3 plus or minus I square root of 15. And then one more step and you're done. So to get x by itself, I'm going to go ahead and rewrite this. To get x by itself, you're going to divide both sides by 2. But you do one side, you do the other. 2 divided by 2 is 1. 1 times x is x. I get x equal 3 plus or minus I square root of 15, all divided by 2. One thing I want you to notice, though, is that now you can write your answer like this, so that's fine. But I want you to notice there are 2 solutions, right? There are 2 solutions. 2 solutions. One says 3 plus I square root of 15 divided by 2. The other one says 3 minus I square root of 15 over 2. So keep in mind that this involves 2 solutions. This equation here has 2 solutions. They're imaginary numbers. They involve imaginary numbers, but there are 2 solutions. The other thing you can do is you can write as 2 separate fractions like this, right? So you can say 3 halves plus or minus I square root of 15 divided by 2. You can say the same thing here. 3 halves minus I square root of 15 divided by 2. Same thing here, right? You could have said, I'm going to write this as 3 halves plus or minus I square root of 15 divided by 2. All of these are equivalent. They are all equivalent. But most students will, when the solutions involve imaginary numbers, they'll write it like this. They're writing this little compact form, if you want to call it that. Okay. All right. So the answer here would be 3 plus or minus I square root of 2. I'm sorry, square root of 15 rather, all divided by 2. Now the problem had said, just to remind you, the problem had said write in the form a plus bi, just like it did here. Then you'd want to write it like this: a plus or minus bi. All right. Okay, so that's the solution to the in-class activity for day 1.